In our previous theory video, we've covered looking at the intersection of lines and circles, and we've covered the three possible ways this can occur. So that was one of them where the line cut the circle twice, another one where it touched the circle once and it was a tangent to the circle, and the third scenario where it was just in the space outside the circle and didn't touch at all. What I'm going to do here is I'm going to present to you 4 questions. I want you to pause the video, have a go at them, and then come back and check your answers with what's presented here. Just remember in each of them, the 4 steps that we talked about in the previous video for going about answering one of these questions. Here you go. So the first 3 questions are, here's the equation of a line, here's the equation of a circle, do they intersect, and if so, what are the points? And the final one is, I'm giving you the equation of a line, but the constant at the end, the plus c, is given as just a generic variable. I want you to determine that based on the condition that it's a tangent to the circle. So pause the video and have a crack. First question. Does the line y equals 4 intersect the circle x squared plus y squared plus 2x plus 6y minus 10 equals 0? If so, what are the points of intersection? Now remember, when we talked about answering these sorts of questions, there were 4 steps that we said. Step 1, we have to get it in the straight line form. So y equals mx plus c. Step 2, we substitute it into here. Step 3, we then rearrange that to get a quadratic in the classic form, ax squared plus bx plus c equals 0. Then we use the discriminant and determine the values from there. If we end up with 2 roots, intersects twice. 1 root is a tangent, no roots, it doesn't touch at all. So let's have a look at this. First one, y equals 4, well that's in the form that we want. There's just no x variable here. So the step that we now have to jump to is substituting it in. So I'd then say fine, so that gives me x squared plus 4 squared plus 2x plus 6 times 4 minus 10 equals 0. So now it's just a case of simplifying this and putting it in the form that we want. So I've got x squared plus 2x, and then the constants, I've got 4 squared, which is 16, plus 6 4, so plus 24, so 16 plus 24 is 40, take away 10, gives me plus 30, and that equals 0. So now we've got it in this form, we have to look at the discriminant. So the b squared minus 4ac for this. So b is the 2, a is 1, and c is 30. So I've got 2 squared, take away 4, times 1, times 30. 2 squared is 4, so then take away, so 4 ones are 4, times 30, 120. So that gives me negative 116. So the discriminant, b squared minus 4ac, is less than 0, which means there's no roots to the quadratic, so it doesn't touch at all. So it doesn't touch the circle at any point. So it's the scenario where if we plotted it, we'd have the circle, and the line would be some sort of a generic line out there. Second question is the same sort of scenario. I'm just giving you a slightly more complex straight line equation because I've got the x variable in here. But our steps don't change. First one, write it in the form y equals mx plus c. So I have to rearrange this, and I rearrange it to get y equals 3x minus 10. What I now do, same step again, is substitute it into there. So I've got x squared plus 3x minus 10 all squared, plus 2x, plus 6 times that bracket again, so 6 bracket 3x minus 10, take away 10, and that equals 0. So now, all we have to do is multiply the brackets out, gather the terms together, and we're laughing. So we've got x squared, multiply this bracket out here, I get 9x squared, take away 60x, plus 100, I then just got the plus 2x there, multiply the second bracket out and I get plus 18x, take away 60, take away 10, all equal to 0. Now that I've got that, I just gather the like terms together, and that's me got it as simple as I can. It's got me got it in the quadratic form that I want. So I get 10x squared, and for the x terms I've got minus 60 plus 2 plus 18, so that's minus 60 plus 20, take away 40x, I've then got plus 100, take away 60, take away 10, so that's 100, take away 70, plus 30 equals 0. I could take out 10 as a common factor for these, so I get 10 bracket x squared minus 4x plus 3 equals 0, and if I use the discriminant, I've now got easier values to use. I could stick with it in this form, I'd just have bigger numbers to work with. So if I take this and I use my discriminant, my b squared minus 4ac, what I end up getting is negative 4 squared, take away 4, times 1, times 3. Negative 4 squared is 16, take away 4 times 1 times 3, is take away 12, that equals 4. So my discriminant is positive, so therefore I've got 2 points of intersection. So now I have to find them. To do that, I take the bracket here and I solve the equation. So I take my x squared minus 4x plus 3 equals 0 and I solve it. Now remember, we can just get rid of the 10 here. 10 never is 0 all on its own, so it's 10 times something that gives you 0, which is this. I end up getting x minus 3, x minus 1 equals 0. So from this, I can simply say that x equals 1 and x equals 3. To get the y, I substitute it back into here. So if x is equal to 1, it's easier to put it in this one. 3 ones, take away 10, so 3 minus 10 gives me negative 7. And if I've got x equal to 3, 3 3s are 9, 9 minus 10, that's negative 1. So my 2 points of intersection are 1 negative 7 and 3 negative 1. Don't forget to put it in this form at the end. This isn't a coordinate. These aren't points of intersection. These are values. Put them in the right format for them being points and coordinates. Third question, the circle x squared plus y squared minus 4x plus 2y plus 3 equals 0 cuts the x-axis at 2 points. Determine these. Well, the equation for the x-axis we have to think about. It's a straight line going across, but it goes across on y equals 0. So for that one, I can simply set y equal to 0. So what I then get is x squared minus 4x plus 3 equals 0. If I solve this, then I should be able to get my 2 points. So if I take this, factorise it, I get x minus 3, x minus 1 equals 0. So from that, I know that x equals 1 and x equals 3. Now I know it's on the x-axis, so I know y equals 0 for both of these. So I can write down my 2 points from that. I've got a point at 1, 0 and a point at 3, 0. So there you go, I've got my 2 points there. It looks a lot more intimidating than it is because I've got no y equals mx plus c version of the equation. However, I'm told it's the x-axis, and on the x-axis I know y equals 0. That there's the equation format we use. If it said y-axis here, I'd use the fact that x equals 0 all the way up and down that, and I'd have x equals 0 as my format. Final question, for what values of k is the line x minus y equals k a tangent to the circle x squared plus y squared equals 18? Now remember, for a tangent, there's one route. There's one point where it can touch, so that's what we have to take. And it's still the same set of steps. X minus y equals k, rearrange it to y equals mx plus c. So from that, I say y equals x, take away k. Now remember, the k is the variable we're trying to find. It's not a variable we know. Substitute it into here, and I get x squared plus x take away k all squared equals 18. Multiply out this bracket here, I get x squared plus x squared take away 2kx plus k squared equals 18. So I've multiplied it out. All I need to do now is simplify everything and get it equal to 0. So I get 2x squared take away 2kx plus, in a bracket, k squared take away 18. I'm going to keep this in the bracket because that's the equivalent of the c part. I then use my b squared minus 4ac. But I know for a tangent, that equals 0. So when I substitute in the values, I'll get an equation and I have to find the solutions for k where it equals 0. So b squared, so that's negative 2k squared, take away 4 times 2 times the k squared minus 18 equals 0. That's what I'm trying to solve. So negative 2k k all squared gives me 4k squared, and then it's take away 8 bracket k squared minus 18 equals 0. Multiply this one out and simplify it. I get 4k squared take away 8k squared, so I get negative 4k squared plus, well, 8 times 18 is 144, and that equals 0. So now I've got this, I need to factorise this side and solve it, and I'm laughing. Well, if I take 4 out as a common factor here, I get 4 bracket 36 take away k squared equals 0. Now again, focus on just the brackets part, the 36 take away k squared. Well, 36 take away k squared equals 0. This part here can be factorised using a difference of two squares. 36, remember that's 6 squared. So what that means is I can say 6 take away k, 6 plus k equals 0. And from that, I get that k equals 6 or negative 6. Now, I've got two values of k there. I've given no condition on k at this point, so I have to take them both. If here it said k has to be bigger than 0, I'd obviously take the plus 6. If it has to be less than 0, I'd take the minus 6. Look at the conditions for that one, okay? If you don't get given any conditions, you have to take both values of k. These kind of questions crop up all the time. It's about remembering these key steps and remembering the key conditions. So remembering, first get your line in the y equals mx plus c formats, substitute it into the circle equation, get it in the quadratic format, x squared plus bx plus c equals 0, then use the discriminant. And remember the three conditions you get on the discriminant. Bigger than 0, you get two roots, so you get 2 points of intersection. Equal to 0, you get one root as a tangent. Less than 0, no roots, no points of intersection, so it's just out in free space somewhere around the circle.